So good morning, everyone, and welcome to this lecture. This is lecture number 8 in Newton laws. Let us have a quick recap of what we had done in the previous class. What we did in the previous class? I think we were dealing with
Static friction, sir.
static friction, and I think we had done some problems on static friction where we were
Yes,
able to understand static friction is what I call intelligent friction. It can change its magnitude, it can change its direction depending on from where or what is required. And we have seen that the maximum value of static friction that cannot change, and that is equal to mu s multiplied by n. It can only be changed if I change the value of mu s or I change the value of n. We'd also seen examples how to change the value of n if I change my angle, my n changes, and all those. Do we remember this?
yes, sir.
In this class, what we are going to do is we are going to do this concept of inertial reference frame, and we'll see some example of inertial reference frame and non-inertial reference frame, and just remember simple things that we are going to discuss. Remember, whenever a question of this nature comes, if it is a simple question, it is going to be pretty good. If it is a difficult one, it will take a lot of time, and we don't have that much of time. So we'll only concentrate ourselves into those questions which are most likely to come. Yes or no?
Yes, sir.
So to first get off, understand about this, we have discussed frame of references previously as well. The first chapter that we started with motion in 1D, everything was studied with reference to the ground frame. Yes or no? Then we moved on to relative motion, and we saw that sometimes the motion may be easier to study from some other reference frame because it looks simpler. Yes or no?
Yes, sir.
Okay, but now what we are going to see is how many types of how many types of reference frames are there. And whenever we talk about the types of inertial type of reference frame, there are two types of reference frame that we have. The first one is known as inertial reference frame, and the second one is known as
Non-inertial.
non-inertial reference frame. I hope you know what do you mean by inertial reference frame, or what do you mean by non-inertial reference frame. So we'll quickly go through it. What do you mean by inertial reference frame? So how do I define inertial reference frame? Any reference frame which is at rest or moving with uniform velocity with respect to another inertial reference frame can be taken as an inertial reference frame. So basically, in the definition of inertial reference frame, we are defining inertial reference frame from another reference frame, because remember, rest and motion are relative terms. So if I have one inertial frame which I understand that is inertial, let us for example say this pen is an inertial reference frame, then anything with respect to the pen which is at rest or which is moving with uniform velocity. Remember, in physics, rest and uniform velocity mean the same thing. The only
Yes.
only thing that differentiates is the acceleration. So any reference frame with respect to any reference frame which is at rest or which is moving with uniform
Uniform motion.
velocity with respect to another reference frame which is inertial is known as an inertial reference frame.
Inertial reference.
To get to an inertial reference frame, it is a very difficult task because we'll have to move to somewhere in space which is far distance from all the planets and all the galaxies. There probably we will find an inertial reference frame, but for all practical reasons, the problem that we are going to do in physics in this class, earth will be taken as an inertial reference frame, but in actual theory, earth is not an inertial reference frame. But for us, for our consideration, earth or ground will be taken as earth or ground can be taken as an inertial
reference frame.
IRF, inertial reference frame. So anything which is moving with uniform velocity with respect to Earth, or anything which is at rest with respect to Earth, can be taken as an inertial reference frame. Do we understand this?
Yes, sir.
The most important thing here is Newton's laws of motion are only valid in inertial reference frame. Newton laws are only valid in inertial reference frame. Therefore, whenever we are writing Newton laws with respect to Earth, we are considering Earth as an inertial reference frame, and that is how we are going to write the laws. Do we understand this? Yes or no?
Yes, sir.
Then the second type of reference frame,
Non-inertial reference frame.
non-inertial reference frame. So once you understand inertial reference frame, you can understand what is a non-inertial reference frame. Any reference frame which is not inertial is non-inertial. So you can write it that way, or any reference frame which is any reference frame that is accelerating
Accelerating. Yes, sir.
with respect to an inertial reference frame is taken as a non-inertial reference frame. Do we understand this? Yes or no?
Yes, sir.
Okay, now remember the most important point. Newton's laws of motion are not valid
Valid for non-inertial frames.
for NIRF. I call it NIRF, non-inertial reference frame, are not valid for non-inertial reference frame. So what do we do? To make them valid, we apply fictitious force. To make them valid, we apply a fictitious force, and this fictitious force is known as, to make Newton laws valid in this frame which are not valid. So we sort of add a term in this Newton laws. We apply a fictitious force, and that fictitious force is known as pseudo. Pseudo means fictitious, does not occur naturally. It's not a naturally occurring force. It's not a force that occurs by interaction of particles. It is a force. It is not a real force at all. It is an imaginary force. That force is known as the pseudo force. Do we understand pseudo force? Yes or no?
Yes,
No,
sir.
yes. I hope everyone is noting it down. So what do you mean by a pseudo force? Pseudo force. The first thing, it is not a real force. It is not a real force, but it is an imaginary force. It is not real, but an imaginary force. It is applied if equations of motions are made from NIRF. Do you understand the meaning of NIRF?
Yes, sir.
Non-inertial
Inertial
reference frame.
reference frame.
If you are trying to make the equation of a body from a non-inertial reference frame, you will have to apply this force which is known as
Pseudo force.
the pseudo force. Now, how much is the value of this pseudo force? Pseudo force is a vector. So magnitude of pseudo force will be equal to m into a. What does m stand for? M stand for the mass of the particle on which you are applying the pseudo force. And a is the acceleration of your reference frame. The frame from which you are applying that pseudo force. A is the acceleration of that reference frame. M is the mass
of
of the body on which you are going to apply that force. The direction of pseudo force. The direction of pseudo force What is the direction of pseudo force? It is opposite to the acceleration of your reference frame, which is your non-inertial reference frame. So, for example, I have this reference frame, which is a non-inertial one. Oops, what have I drawn? If I have this reference frame, which is a non-inertial one, I have not drawn it correctly. Let me draw it correctly. If I have this reference frame, what is happening? What the hell I'm doing? Oops. Let us say if I have this wedge. Okay, now it is correct. If I have this wedge and I'm sitting on the top of this wedge, and this wedge is accelerating with an acceleration A. This wedge is accelerating with an acceleration A with respect to ground. And I want to make the equation of this block whose mass is M. If I want to make the equation of this block sitting from this wedge, so what I need to do? I need to apply which force?
Pseudo force.
What will be the magnitude of the pseudo force? Mass of this
Mass of
block
the particle
into the
to
acceleration.
acceleration.
And what will be the direction of pseudo force?
Opposite to the acceleration of reference frame.
So the pseudo
Yes,
force
sir.
would be applied like
MA.
then I can write Newton laws of motion, and then Newton laws of motion can be applied in that way. So this is a cheat method of applying Newton laws of motion to non-inertial reference frame. Do we understand this? So whenever we have to make equation of motion from a non-inertial reference frame, why will we require to make equations? Because in some cases those equations, some questions are easier to solve from some other reference frame. That is when we will need to change our reference frame. When we need to change our reference frame, and if it is a non-inertial reference frame, we will have to apply these pseudo forces. Do we understand this?
Yes, sir.
Then let us solve a problem based on this. This is famous problem where we have a lift problem of lift and the weighing machine. So this is the problem. This is a lift and it has a weighing machine, as you can see, and it has a man standing on this weighing machine. The mass of this man is M. Now there are different cases cases made in this, and they ask you what is the reading of the weighing machine. So example, if I say case number 1, this is moving up with a constant velocity v. This lift is moving up with a constant velocity v. And then if someone asks you what is the reading in the weighing scale, so what will be the reading in the weighing scale, or what will be the weight of this body which will be read in the weighing scale? If it is moving upwards with a velocity, the weight will be equal to same mg.
G.
It will not change. If it is moving down with a uniform velocity v, in that case also the weight will remain
MG.
mg. It does not change. Nothing changes. But if it is now moving up with an acceleration a, if this moves up with an acceleration a, what happens is, to understand this, what will happen is, let me sit on the, let me become a Hulk and hang on this lift and see what is happening here. So as soon as I understand that this is uh what non-inertial reference frame, I will have to apply a pseudo force on this body. Yes or no?
Yes, sir.
That will be equal to mass of this body
Mass
m into a, and it will be
acceleration.
downwards. Yes or no?
Yes, sir.
Now, if I draw the free body diagram, this normal reaction is n, and the weight of the body is mg. Yes or no?
Yes, sir.
Now, what this weighing machine reads as weight is actually the value of this n. Yes or no?
Normal. Yes, sir. Yes, sir.
Now, if I now see the value of this normal reaction, what will be the value of this normal reaction? This normal reaction is upwards, the body is at rest, because when I see it from the left, it is at rest. This
Yes.
normal reaction will be equal to m into,
Mg.
this normal reaction will be equal to m into
Mg.
g plus a, and therefore we will see
Okay.
that the weighing machine will read its weight more
Yes, sir.
than what it actually is. Do we understand this? Yes or no?
Yes, sir.
So when this lift is moving up, the weight that will be read in the weighing machine would be m into g plus a. What happens when it moves down with an acceleration a? When it moves down with an acceleration a, you will have to apply a pseudo force up,
Opposite.
which
Yes,
will
sir.
be equal to m into
Ma.
a. In that case, what will be the normal reaction or weight of the body?
M into G minus A.
M into G minus A. Do we understand this? Yes or no?
Yes, sir.
Now, if the lift is in free fall, the link has broken, the rope has broken. If the lift is in free fall, the value of normal reaction, because then the acceleration A will become equal to G, then the normal reaction will be 0, and the reading of the weighing machine would be
Will
0.
be zero.
Do
Yes,
we
sir.
understand this? Because both the weighing machine and the man will be in free fall, and the lift also in the free fall. They will not be able to exert any weight or normal reaction on each other. Do we understand this? So
Yes,
this is
sir.
an implication of this pseudo force. I'll give you 2 minutes to note it down. Please note it down.
Done, sir. Sir.
Yes, beta. Yes.
Yes, sir. Done, sir.
Just give me a minute, beta. Yes. Okay. So we have understood this. Now, if any question comes on this pattern, this is how you need to solve them. So let me now give you this question, and I hope you are able to solve it. Again, the question of a lift. So this is the lift that I've created. Question number 2. This lift, in this case, is moving up with an acceleration A. Then I have two blocks in the lift, M1 and M2. Or let me not call them M1 and M2 because let me give you some values here. So the value of this block is M and the value of this block is M. Acceleration due to gravity is G, and this acceleration is, let us say, G by 2, so that everything comes in terms of some values. So this acceleration is G by 2. You have to find the acceleration of M and 2M with respect to lift and with respect to ground. I'll give you 2 minutes to solve this. Take your time.
Yes.
Yes, Bacha, do you want any help? Shall I help you?
Yes, sir.
Okay. So this is how you do it. You draw the free body diagram. The best way to do this question is by sitting inside this. So I will sit inside this and I'll make this equation. Now let us, as soon as I sit inside this lift is going up. So I have to apply a pseudo force on this block. It will be equal to m into g
mg.
by 2. Yes
Yes,
or
sir.
no? All these
Yes,
green
sir.
forces are pseudo forces. 2m
2
into
mg by 2.
2. Okay. Now I apply the forces which I see in this system. One is tension T, yes or no? One is
Yes.
the weight mg, yes or no?
Yes, sir.
Here also tension T and here also weight 2
2
mg.
mg.
Yes or no?
Yes, sir.
Inside, from inside the block, whatever acceleration I see, that will from inside the lift, whatever acceleration I see, that will be acceleration with respect to the lift. Yes or no?
Yes, sir.
From the lift, I will see that this block is going down with an acceleration a. This
A.
is, and this block will come up with an acceleration a. Yes or no?
Yes, sir.
Now look at this, look at this, look at this, and look at this, and tell me the equation for this block.
T. T minus m
T minus
minus
mg
mg
minus mg by 2
mg by
is
2
equal to ma. Do we
ma.
understand this? This is the equation from inside the lift for the block of mass m. Yes or no?
Yes, sir.
Let us look at the other things. This is T, acceleration is downwards. This is the force downwards. This is the force downward. What is the acceleration for this block? What is the equation for this block?
2 mg by 2 minus 2
2
mg.
mg by 2 is basically mg. mg,
mg minus 2 mg.
mg plus 2 mg.
Okay.
Both are downwards. Minus T
Minus t is
is
equal
equal to
to ma.
2m into a. Do we understand this?
Yes, sir.
Everyone understand this? Yes or no?
Yes, sir.
I'm not getting real sense from everyone. Do we understand this?
Yes, sir.
Boys, do we understand this?
Yes, sir.
Okay. So this is how now you solve and get the value of this acceleration first. That will be this A. That acceleration that you get will be the acceleration of the blocks with respect to the lift. Do we understand this?
Yes, sir.
Please find it out first. To do that step, I'll give you a minute to find it out.
Sir, acceleration is 3 mg by 2m.
So you are getting it as how much?
3 mg by 2m.
You can cancel m, no? Yes or no? So the answer is acceleration you are getting is 3g by 2. Yes or no?
By 2, yes, sir.
Okay, 3g by 2. So now I can write, remember, I'm just going to write simple thing. Acceleration of, I have to write in vector form, m with respect to left, m with respect to L is 3g by 2 and it is upward. So I'll write it as j. Do you understand this? Acceleration of 2m mass with respect to left is 3g by 2 in the downward direction. So I write it as minus 3g by 2 in the direction of j. Do we understand this? Minus 3 by 2, minus 3g by 2j. Do we understand this? Yes or no? Acceleration of lift with respect to ground, it is moving up. So its acceleration is g by 2 along j. G by 2j. Yes or no? Now if I have to find out the acceleration of m with respect to ground, now this question is very unlikely to come. Acceleration of m with respect to ground, what do? I find the acceleration of m with respect to lift and add the acceleration of lift with respect to ground. Do we understand this? I told you that you can put L in between and this is how you will get. So if I add these two, I will get the acceleration of block M with respect to ground and it will be 3g by 2j plus g by 2j. So your answer will come as 2g in the direction of j. If I have to find out the acceleration of 2m block with respect to ground, how will I find it? I will find it acceleration of 2m with respect to lift plus acceleration of lift with respect to ground. So I need to now add this with this. If I add this with this, what will I get? I will get minus gj. Do we understand this? So this is how, if this question comes, if such a question comes, this is how we need to solve it. Anyone got this? Yes or no? Can I have raise hands from everyone that we understand this?
Sir.
Okay. Note this down. I'll give you a minute to note it down. Have you noted it down, everyone, beta? Do we have any
Done,
doubt?
sir.
Noting down or noted?
Done, sir.
Okay. Then we can do this problem, one more problem, and we are done with this. This problem has come many times, and that is why, and you can just remember the result. That is more important. You just try this problem and then just remember the result of this problem. That is what you need to remember, nothing else. So try this problem. A pendulum mass m is suspended from the ceiling of a train moving with an acceleration a. Find the angle of this bob in equilibrium. When it is in equilibrium, what is the angle of this bob with respect to the vertical axis? This is what they are asking. Okay, I'll give you 2 minutes to solve this. Can I help you, beta?
We are doing, sir.
Okay. Give you 2 more minutes. Try it.
Yes,
If
sir.
not, then I'll help you out. And remember, you don't have to do this question in the examination. All you're just spending time here so that you understand the concept. So if not the same but a similar question comes, you should be able to do it in the examination hall. If the same question comes, you should be able to remember the results because these results are going to come in many places. So I give you the result. You'll have to remember that result. Try it. So trial is just for if a similar question comes, not the same one, how to attack. That is the reason we are solving it. Else we just need to remember the result of this one. Can't hear you, bacha now. Yes, bacha. So how are we supposed to do this? It will stay in equilibrium at this angle theta. Do you see this? This is moving here with an acceleration a. So if I have to make this equation by sitting here, what I need to do is I need to apply a pseudo force. Yes or no?
Yes, sir.
Like this. Then we have this weight of this block mg. This will be the effective g that is going to come. So you just remember these things about this. This tan theta, this angle of inclination, you can easily find it out. This angle theta is same as this angle theta. Yes or no, my dear friends? That will be equal to m into a divided by m into g. So that becomes equal to a into g. Do we understand this? Yes or no? Did we get how did I do this? We understand this. The block is in equilibrium. So this angle and this angle are all equal. So the angle tan theta becomes a by g. Yes or no? Then they might ask you the value of g effective. So just note down these points. They might ask you the value of this g effective g here. So the value of effective g here is under root of a square plus g square. Do we understand this? Then we have this tension T here. They can also ask you the value of this tension T. So you can remember that T cos theta is equal to mg and T sin theta is equal to ma. And this T becomes your m into g effective. So that becomes equal to m into under root of g square plus a square. If you remember these things, this question or question like this, you can do very, very quickly. Do we understand this? Yes or no? No, yes. I'll give you 2 minutes to note this down, bacha. Have you noted this down, beta? Yes or no? No, yes. Okay, so these are the things that you must remember if a question comes. Okay,
Yes, sir.
then again, I will give you examples of questions which are going to come in the examination hall, and you just have to remember their results because you might not get enough time to solve them. So remember this example as well. And one more example that I'm going to show you. So in this example, what is happening here is, bacha, I hope you can see this example now. We have a block which is kept in contact with a moving wedge or a moving cart. And the question is, if the coefficient of friction between the block and the cart is mu, what should be the acceleration of this block? What should be the acceleration of this block so that this block does not fall? What should be the acceleration of the wedge so that this block does not fall? If this question comes, how are you supposed to do this? Don't have to do this because you will not get this much time in the examination, or you will sit on the top of this and then you will write the equation of this block. When you write the equation of this block, you will have to apply a pseudo force ma, yes or no? You'll have to apply a pseudo force ma, then the other force will be mg, and whatever is trying to stop it will be static friction, yes or no? So the static friction will be equal to mg, and the value of this static friction is mu into m into a. If you do all these calculations, you will end up with the value of a. So remember, the value of a that you must have should be equal to g by mu. I hope you understand how I have achieved this. Fs will be equal to mg, and this Fs will be equal to mu into m into a. From there, I have got the value of a. Remember this result because this is a question that has come many times and it may come straight away in your exam. So I'll give you 2 minutes to note it down. Let me know once you are done, bacha.
Okay, sir. Done, sir. Done, sir.
Okay, then one more result that you must remember, and I will give you the result. This result is for a wedge which is moving, and how does this result look like? Let me draw that wedge for you, and that is again a very common question that has come many times in the exam. So the question goes like this: you have a wedge which is inclined at an angle of theta, and you have a block which is on the wedge. Now the question is, there are two types of question that can be asked. What can be the acceleration of this wedge if the block has to remain at rest? So first question is, what is the value of acceleration for which block remains at rest with respect to the wedge? With respect to the wedge, the block remains at rest. What must be the acceleration of this system? So how should I move it? What should be the acceleration? Remember, in this case, the acceleration will be in this direction. Do we understand this?
Yes, sir.
And the value of acceleration should be equal to g tan theta for this block to remain
At rest.
with respect to.
Wedge.
Second question they may ask is, what should be the value of this acceleration so this block is in free fall? The block is freely falling. In that case, this acceleration should be in this direction and the value will be equal to g cot theta.
Content.
Remember these two things. Don't get confused. Remember the direction and remember the values, because in the examination hall you will not get enough time to actually solve this question. You will have to remember the result and use it accordingly. Do we understand this? Yes or no? No, yes.
Yes, sir. Yes, sir.
Please note this down. Once you note it down, please let me know.
Done, sir.
Done, sir. Then this brings us to an end of this class and this topic. We are done with Newton laws of motion and friction. In the next class that is going to come tomorrow, we will start with work, power, energy, and our main intention would be to finish work, power, energy by the end of this week or maybe the beginning of the next week. Remember, we are only trying to concentrate on those questions which are more likely to come, because some topics are so big that even if I take your entire year, I will not be able to cover them. I hope you understand this, right?
Yes,
So
sir.
I'm trying to concentrate only on those questions which are more likely, most likely to come, and the sort of questions that are coming these days in the exam and what the examination pattern is all about. So I'm only concentrating on those questions. I've seen those questions that are coming. That's why I'm giving you all these questions which are more likely to come. So I'll continue with this within the chapter on work, power, energy, so that we can cover some lost ground. Take care. Have a nice day. And God
Yes, sir.
bless
Have
you
a
all.
nice day. Thank you, sir.
Take care, beta. Bye bye.
Thank you, sir.